Rule number 5, or the product rule of derivative, or how we can find the derivative of a product rule. And we mean here by the product rule that we have two functions. It's a little bit difficult to simplify them and write them in terms of sum of power of x. So we are using a rule which says that the derivative of u times v, where is u is the first function and v is the second one, is equal to derivative of the second multiplied by the first plus derivative of the first multiplied by the second. The derivative of a product is actually the sum of the two products, but not only the sum of the two products, it's the sum of the first function multiplied the derivative of the second plus derivative of the second multiplied by the first. Let me give you an easy example here so you can understand it. If y is equal to x squared e to the power of x, y is equal x squared e to the power of x, I can't simplify this function and write it as one function, okay, or one term of x. It's two functions actually. So I'm going to write u and v. U is the first function, which is x squared here, and v is the second one, which is e power x. How I can find the derivative of x squared? The derivative is 2x. And how I can find the derivative of e power x? Derivative of e power x is e power x. Derivative of e power x is e power x. So dy by dx is equal u dash v, so it's 2x e power x plus x squared times e power x. So it's a cross product here, or the sum of the cross product between u and v, u dash and v dash. Use the product rule to find the derivative of y. Derivative of y is dy by dx. I'm not going to simplify the brackets, I'm going to use the product rule. So first I'm going to start by the product rule. D by dx for uv is equal u dash v plus v dash u. Don't forget the rule. So I'm going to write that u, which is the first bracket, 5x squared minus 3x plus 2. And v, which is x to the power 5 minus 4x plus 3. So u dash, the derivative of u, is 10x minus 3. And v dash is 5x to the power 4 minus 4. I'm going to make a cross multiply and find the sum of the cross product or the cross multiply of these. So dy by dx is equal to 10x minus 3 multiplied by x to the power 5 minus 4x plus 3 plus 5x to the power 4 minus 4 multiply 5x power 2 minus 3x plus 2. You are going to keep the question like this if I'm not asking about the simplest form of the derivative or the simplest form of the equation. But if I'm asking about the question is asking about the simplest form or reach its simplest form, you are going to multiply 10x by x power 5, which is 10x to the power of 6, and 10x by negative 4, negative 40x squared, and 10x by 3, which is 30x. Then negative 3 by x power 5, and negative 3 by negative 4 is positive 12x, and negative 3 by 3 is negative 9, plus 5 times 5 is 25x to the power of 6. 5 multiplied by negative 3 is negative 15x to the power of 5. 5 multiplied by 2 is 10x to the power of 4. Then negative 4 by 5 is negative 20x to the power of 2. Then positive 12x and negative 8. Let's highlight the like terms. I have here 10x to the power of 6 with 25x to the power of 6. I have negative 3x to the power of 5 with negative 15x to the power of 5. Also I have x to the power of 2 with x to the power of 2, and I have 30x with, no, this is 30x with positive 12 and positive 12, and finally negative 9 and negative 8. So dy by dx in its simplest form is 35x to the power of 6 minus 18x to the power of 5, then plus 10x to the power of 4, and negative 40 and negative 20 is negative 60x squared, plus 54x minus 17. To find the derivative dy by dx of y by using the product rule, d by dx for uv is equal u dash v plus v dash u. Let's try this time to find the derivative directly without writing u and v. So I'm going to write dy by dx is equal derivative of this bracket, which is 12x minus 4, multiply the second bracket, which is x power 4 minus 3x squared plus 6, then plus derivative of this one, 4x power 3 minus 6x, multiply the first one, 6x squared minus 4x minus 6, and then we start simplifying. 12x by x is 12x to the power 5 minus 36x to the power of 3 plus 72x after I multiply 12 by 3 and 12 by 6. Then I go back to negative 4. It's going to be negative 4x to the power 4 plus 12x squared minus 24. Then again 4x power 3 times 6 is 24x to the power 5 minus 16x to the power 4 minus 24x power 3. Finally, negative 6 by 6 is negative 36x to the power of 3. Negative 6 by negative 4 is positive 24x to the power of 2. Negative 6 by negative 6 is positive 36x. Let's add the like terms. So dy by dx is equal 12x power 5 and 24x power 5 is 36x to the power 5. Negative 4x power 4 and negative 16 is negative 20x to the power 4. Negative 36 and negative 36x power 3 and negative 24. Negative 36, negative 36 and negative 24. Negative 36 and negative 36 is negative 72. Negative 72 and negative 24 is negative 96x to the power of 3. 72x and 36x is 108x. 12x squared and 24x squared is 36x squared. Finally, I have negative 24, so minus 24. Find dy by dx for the given using the product rule. So first, I'm going to write the derivative of the product rule, which is u dash v plus v dash u. So this is u and this is v. So dy by dx is equal derivative of these 2x plus 3, multiply the second bracket, plus derivative of that, multiply the first bracket. And now let's simplify it. 2x multiplied by x squared is 2x to the power of 3. 2x multiplied by negative 5 is negative 10x squared. 2x multiplied by 2 is positive 4x. Then 3 by x squared is 3x squared minus 15x plus 6. 2 by x is 2x to the power of 3. 2 multiplied by 3 is 6x squared. 2x multiplied by 1 is 2x. Negative 5 by x is negative 5x squared. Then negative 15x, negative 5. Let's add the like terms. 2x power 3 and 2x power 3. Negative 10x squared and positive 6x squared and negative 5x squared. 4x, I forgot something, 3x squared, sorry. 3x squared. And 3x squared, and then 4x with 2x, 4x with 2x, this one is in green with negative 15x and negative 15x, finally negative 5 and positive 6. So again dy by dx is equal 2x power 3. 2x power 3 is 4x to the power of 3. Negative 10, positive 3 is negative 7, positive 7 is negative 1, negative 5 is negative 6. Negative 10, positive 3 is negative 7, negative 7 plus 6 is negative 1, negative 5 is negative 6x squared. Then 4 and negative 15 is negative 15 and negative 15 is negative 30. Negative 30 minus 6 is negative 24x, and positive 6 and negative 5 is positive 1. Find dy by dx by using the product rule. First, I'm going to write y as 4x squared minus 1. After simplifying these two brackets together, it's a difference of 2 squared, multiply 4x squared plus 1. I know that it's easier to write y in the form of 16x squared minus 1 and find its derivative, but we need to apply the product rule. D by dx for uv is equal u dash v plus v dash u. We assume that u is the first function, which is 4x squared minus 1, and v is the second one. So u dash is 8x and v dash is 8x. So dy by dx is equal 8x multiply 4x squared plus 1 plus 8x multiply 4x squared minus 1. So 8x times 4 is 32x to the power of 3 plus 8x after I expand the bracket. 8x times 4 is 32x to the power of 3 minus 8x after I expand the bracket. So I cancel positive and negative. So dy by dx is equal 64x to the power of 3. 64x to the power of 3. Use the product rule to find the derivative of y by using the product rule. We know that d by dx for uv is equal u dash v plus v dash u. So we assume that u is root x plus 1 plus 1 over x squared, but I'm going to write it as x to the power of half plus 1 plus x to the power of negative half, and v, which is x to the power of half minus x to the power of negative half. U dash will be half x to the power of negative half minus half x power negative 3 over 2, and v dash is half x to the power of negative half minus, it's going to be plus half x power negative 3 over 2. Now let's write dy by dx. So dy by dx will be half x power negative half minus half x power negative 3 over 2 multiplied by x power half minus x power negative half plus x to the power of half plus 1 plus x power negative half multiply half x power negative half plus x half x power negative 3 over 2. I just wanted to write it in a simplest form in terms of positive power, and that's it. So it's 1 over 2 root x minus 1 over 2 the root of x to the power of 3 multiply root x minus 1 over root x plus root x plus 1 over root x multiplied by 1 over 2 root x plus 3 over 2 root root of x to the power of 3, and that's it. I'm not going to simplify it anymore here. Barakallah. By using the product rule, find the derivative of y. I know that the rule for the derivative for uv, the product rule, is u dash v plus v dash u, which is the derivative of the first multiplied by the second plus derivative of the second multiplied by the first. First, I need to simplify y. So the first step I'm going to do is to simplify y, to write it as two terms. So x squared times 2x squared is 2x to the power of 4, and x squared multiplied by 4 is 4x squared, plus 2 times 2 is 4x squared, and 2 times 4 is 8. I'm going to put this bracket down, so it's 5x squared plus 6. Let's add the like terms here. So it's 2x to the power of 4 plus 8x to the power of 2 plus 8 multiply 5x squared plus 6. So dy by dx will be derivative of the first, dy by dx is derivative of the first, which is 8x to the power of 3 plus 16x multiply the second, plus derivative of the second, which is 10x multiply the first. Let's simplify it. 8x power 3 multiplied by 5 is 40x to the power of 5. 8x power 3 multiplied by 6 is 48x power 3. Then 16 times 5 is 80x square, and 16 multiplied by 6 is 96, plus 10 times 2 is 20x to the power of 4, plus 10 times 8 is 80 x square, x power 3, sorry, and here is x power 5. I forgot to add the power. I have here power 1 and power 4, there times 5, power 1 and power 2, power 3, plus 80x square. Let's go to the like terms. 40x to the power 5 and 20x to the power 5. 48x power 3 and 80x power 3. 80x square and 80x square. So dy by dx, the simplest form, is equal 60x to the power 5 plus 128x to the power of 3 plus 160x squared plus 96. Find the product rule to find the derivative of y, which is dy by dx. I know that d by dx for any product rule for two functions u and v is the derivative of the first multiplied by the second plus derivative of the second multiplied by the first. And you can write it as uv dash. First, I need to write y in sum of terms of x, so it's x squared plus 3 plus 2x to the power of negative 2. Multiply by x minus 2x to the power of negative 1. X power 1, down, move up, x to the power of negative 1. So dy by dx is derivative of the first, which is 2x, derivative of 3 is 0, negative 2 by 2 is negative 4, subtract from 2, 1, it's negative 3. Multiply by the second. Plus derivative of the second, which is 1 plus 2x power negative 2, multiply the first. So dy by dx is equal 2x multiplied by x is 2x to the power of 2. 2x multiply negative 2x power negative 1 is negative 4, only negative 4. Why? Because x power 1 times x power negative 1 is give me 0. X power 0, which is equal to 1. Negative 4 multiplied by x is negative 4x power negative 2 after adding the power, plus 8x power negative 4. Then 1 by x squared is x squared plus 3 plus 2x power negative 2, and then 2x squared by x squared is 2, 2x squared by 3 is 6x power negative 2, 2 by 2 is 4x to the power of negative 4. So I have 8x power 4 negative 4 and 4x power negative 4, which is 12x power negative 4. And two x power negative 2, negative 4x power negative 2, 6x power negative 2, so it's 4x power negative 2, and 2x squared was 1x squared, which is 3x squared. And 2 plus 1 is 3. And finally negative 4 and positive 2, positive 3 is positive 1, which can be written in the form of 12 over x to the power of 4 plus 4 over x to the power of 2 plus 3x squared plus 1.